Morning grade 12s. Today what we're going to be looking at is more binomial probability distributions, but today we're going to have a bit more of a take-active focus. Previously the examples were easy enough to do without a calculator. These are more likely to occur in your take-active paper. Okay, it's known that 52% of the population participates in sport on a regular basis. 5 random individuals are interviewed and asked whether they participate in sport on a regular basis. Let X be the number of people who regularly participate in sport. Okay, the first thing we need to do is we need to identify what information we've been given. And we can see that we have 52% over here, and we have 5 individuals. We're looking for an n value, and we're looking for a p value. Okay, let's have a look. A, construct a probability distribution table for X. With any of these questions, we always define the variable first. Highly unlikely in an exam that they're going to define it for you. So let X be the number of people who participate in sport. Okay, now this is binomial because you either participate in sport or you don't participate in sport. 2 outcomes. Okay, so X can be approximated by a binomial in n and p. And we've identified that n is 5, our p is 0.52, and that means that q is 0.48 because it's 1 minus p. That means that X can be approximated by a binomial in 5 and 0.52. Now I'm going to tell you what all the buttons are to push on your calculator. It will seem a little bit overwhelming to start, but once you've done it a few times, it starts to feel okay. So what you're going to push is you're going to push stat, and in list 1, you're going to put 0, 1, all the way up to 5. That's because we're interested in 0 people, all the way up to 5 people participating in sport. We're then going to go to the distribution. We're going to tell it we want a binomial distribution. We're going to go to binomial probability distribution. We're going to tell it we want a list. And we're going to tell it we want it in list 1. Number of trials are going to be 5, and p is 0.52. Don't freak out. Okay? And I'm going to show it to you now on the calculator. Just get my calculator open. So we're going to go to statistics, make it big, and in list 1 we're going to go 0, 1, 2, 3, 4, and 5. We're going to go to F5 for distribution, binomial, and BPD. And you'll see that in data it says variable. We want to make that list, and the list is going to be list 1. Our number of trials is 5, and our probability is 0.52. And the really cool thing about this is it actually gives you the whole list of values rather than you doing each individual one. Okay, you will notice that the rounding isn't quite right because 0.0254 should actually be 0.0255. So I would suggest that you look at this bottom number and just round off appropriately. So let's put those into our table because this is our probability distribution table. So P is X equaling X, and we've got 0, 1, 2, 3, 4, and 5. And we're going to put our values in from our calculator. Remember, you need to always write from calculator. And we've got 0.0255, 0.1380, 0.2990, 0.3240, 1755, and 0.0380. Remember, we're rounding to 4 decimal places when we are working with probability. Okay, so that is your probability distribution table for X. Now, we need to determine the probability that 3 people or fewer play sport. So we're looking for our probability of X being less than or equal to 3. 3 people or fewer. Okay, and for that we're going to be saying using BCD. Now the BCD instead of the BPD actually gives you a cumulative distribution. So it sums all of the probabilities for you. It finds the probability of X equaling 0 plus the probability of X equal 1 plus 2 plus 3. Okay, so let's have a look at that on our calculator. We're going to go exit, we're going to go distribution, binomial, and BCD. And we want to change our data back to a variable. And you'll see it asks for a lower, an upper, and the number of trials. So we're going to have our lower is 0, our upper is 3, because we're wanting less than or equal to 3. Your calculator does be equal to, okay? And the number of trials is 5. Our probability of success is 0.52. And it gives us a value of 0.7865. In terms of what's expected in your exam, you need to communicate what you're putting in on your calculator. So you're going to say, using BCD, you're going to have lower is 0, upper is 3, number of trials is 5, and P is 0.52. And then you're just going to say, therefore, the probability of X being less than or equal to 3 is 0.7865. Okay, now if you added 0.0255 plus 0.1380 plus 0.2990 plus 0.3240, you should get exactly the same. You could also have used one minus the probability of X being greater than 3. You would have got the same answer. Alright, now let's have a look at C. Determine the probability that at least one person plays sport, given that no more than 3 people play sport. As soon as I see that word given, I know I'm talking about conditional probability. Okay, and you need to remember your conditional probability formula. So let's remember that the probability of A given B is going to be my probability of A and B over my probability of B. So let's have a look. Our probability of A in this case is the probability that at least one person. So that's going to be 1 or 2 or 3 or 4 or 5. So what we're looking for there is our probability of X being greater than or equal to 1, given that no more than 3 people play sports. So given that X is less than or equal to 3. So that actually reduces my sample space, and that means I'm actually only interested in the probability of 1 or 2 or 3. Okay, and that means I'm looking from the probability of X being greater than or equal to 1 and X being less than or equal to 3 over my probability of X being less than or equal to 3. Okay, so what I'm actually then interested in is 0.1380 plus 0.2990 plus 0.3240 over, and we calculated that earlier, 0.7865, and that gives me a value of 0.9676. Okay, so therefore the probability of at least one person playing sport, given that no more than 3 play sport is 0.9676. Alright, now let's have a look at D. This is an interesting one. It says determine the probability that the first person interviewed plays sport, but that the next 2 do not. The first thing you need to realize there is that they're saying the first person and the next 2. This requires order. For binomial probability, there is no order. So immediately you need to realize that this is just normal probability. Okay, so order matters. Therefore, it's not binomial. Okay, so therefore, what we're actually looking for is our probability of somebody playing sport, then not playing sport, then not playing sport. It's just like a normal tree diagram, and that would be equal to 0.52 multiplied by 0.48, and that's 0.1198.